All right, so we're going to do some examples of using your half and double angles. So these are some of the questions that we were looking at for our half and double angles. Now the first ones say to find tan 2u or say find sine 2u, which means I'm going to be using my double angle formulas. And of course, you need to know your double angle formulas to be able to do these. So if you remember, these were our double angle formulas. We can get to these formulas, of course, from our sum and difference ones. So if you just know your sum and difference ones and you stick in u plus u instead of u plus v, you can get to these formulas, as you saw in the other videos. So the first one that we're interested in is this one because we're talking about tangent. So when I look at this one, we're looking for tan 2 theta. So we know that tan 2 theta is going to be equal to 2 tan theta over 1 minus tan squared theta. That's just our double angle formula. It tells us that we're looking for an angle. The theta that we're looking for is in quadrant 1 because it's between 0 and pi over 2. So we know that since this is pi over 2 and this is 0, we know that he lives in this quadrant. And we know that the sine is 4 over 5. So we know we're looking at a triangle that looks like this. Okay, so the only thing left to do is to go ahead and put in our other side, and this happens to be one of our special triangles. So it's a 3, 4, 5. And now all I have to do is figure out what tan is for this angle theta, right? This is angle theta. So when I plug in my tangent, we're going to get 2, and tangent is opposite over adjacent, so 4/3 over 1 minus 4/3 squared. So that's going to give us 8/3 over, this will be 9 over 9 minus 16 over 9. So of course 9 minus 16, is that a 7, negative 7/9, I want to say. And now we just multiply by the reciprocal because that's what division is, right? 9 over 7. So these will cancel out, give me a 3. So it looks like 24 over 7, but a negative because of our negative here. And then let's just look at our answers, and here we are, 24 over 7, negative 24 over 7. So looks good, okay? Let's do this sine one. So are there any of these that aren't? Oh, well, let's do a different one. Let's do this one down here. This one is not in quadrant 1 anymore. So let's take a look at this one. This one tells us what our tangent is, and it tells us that it lives between 3 pi over 2 and 2 pi. So where would I draw that one? Well, I should have left a little more room over here. But let me write down my sine formula first, because that actually helps me to remember it if I write it down every time. So sine 2u is cosine u, sine u, cosine u, or cosine u, sine u. It doesn't matter which way you write it. And I know that I'm drawing an angle. This is 3 pi over 2, and this is 2 pi. So my angle is going to live in here. It already told me that. And it told me that the tangent is negative 12 over 5. So I know my opposite side is going to be 12. My adjacent side is going to be 5. This one's the minus. And I can tell that because I know what quadrants it's in. So that's how I know that the negative 12 over 5, that the 5 isn't the negative one, but the 12 is, because I drew it in this quadrant. And how did I know to draw it in that quadrant? They told me to right here. Okay. This happens to be another one of our special triangles. So I know that that side is a 13. Again, if you didn't know, just use Pythagoras. And now all I have to do is plug them in. So what do I need to know? I need to know the sine and the cosine of this angle. So sine 2u is going to be equal to, it's going to be 2, the sine of this guy, which is negative 12 over 13, times the cosine of this guy, which is 5 over 13. And our last thing to do is just multiply all this stuff together, right? So we got, what, 24 times 5? Is that what I see there? 24 times 5. I think that's 120. And 13 times 13, right? That one is 169 So it looks like negative 120 over 169. I don't even think that can be reduced. So here we are, 120 over 169. Okay, we'll do a cosine one also, and then we'll, if there is a cosine one, or we'll just do a cosine one. Oh, here's a cosine one. Here's our cosine. It says, well, let me flip the paper around. So here we are. We have tangent. They gave us tangent again. And they told us that it's between pi and 3 pi over 2. So once again, you have to ask yourself, what quadrant is that in? So what quadrant is it in? Yep, it's in quadrant 3. I know that the tangent is, and that since tangent is positive, I knew it could have been here or here, but they're telling me that it's here. So that's going to be important because I'm using sine and cosine. So if I draw it here, I'll have the wrong signs, S-I-G-N, right? It'll be the wrong positives and negatives. So this tells me where to draw it so that I'll have the correct positive negatives for the sides, right? Okay, so tangent, again, is the opposite over the adjacent. So is this the same exact triangle, I think, as the last one? It's just in the different quadrant. And now I need to do the cosine times the sine. So cosine squared minus the sine, I'm sorry. So it's 5 over 13 squared minus 12 over 13. Oh, I did it wrong, didn't I? Minus. Actually, in this case, it doesn't matter. Does anyone know why? It really doesn't matter. But those are both negatives. So I just got through saying we drew it there on purpose. These sides should be negative because these are negative x's, negative y's. But when I square them, they're going to come out positive anyway. So in this case, I would have actually gotten away with the mistake if I had not made them negatives anyway. But so what's that? 25 over 169, right? 169, I think, is 13. And what's that? 144. And so whatever 25 minus 144 is, it's 119, I want to say. And let's just take a look if that's one of our choices. Negative 119 over 169. Here he is. Okay, so for these double angle ones, all we're doing is we're drawing the triangle that, given the information that they gave us, in the correct quadrant and the correct size triangle. And then we're finding the information for our formulas. It's as easy as that. Okay, so, and it doesn't matter which formula you use in, really all you're doing is just plugging in numbers. And I think most of you can handle plugging in numbers for formula. So let's look at, see if there's any half angle ones here. All right, so now we're getting into these half angle formulas, these half angle questions. The first one is a sine. So once again, I need to know my formulas. Now these are the ones that are a little bit trickier because these formulas have pluses and minuses in them. Not for tangent. Tangent, it doesn't matter as much, you don't have to make the decision whether you're going to use the plus or the minus, but you do have to draw it in the correct quadrant because if you draw it in the wrong quadrant, you will have the wrong sign. So these ones will be decided by the triangle, and these ones we're going to have to decide based on the information in the question. Now, hopefully all of you can see inside here that I'm always going to get a positive inside because what's the biggest value cosine can give us? It's 1, right? So if I have 1 minus cosine, this is still going to be positive. Or if I have 1 plus cosine, this is still going to be positive. And so these will always yield positives. Obviously, the square root's always going to yield a positive. So we have to decide if it's going to be positive or negative based on the quadrant that the angle is going to lie in, okay? So we're going to decide that based on the information from the question. So let's take a look at this first one. We're looking for sine theta over 2. So we know that sine of theta over 2 is simply plus or minus the square root of 1 minus cosine u over 2. And you saw where we got these formulas from in the last video, right? So we did those in the other video. If you're curious as to how to get to those formulas, sometimes it helps to know where they came from. It makes it a little bit easier to remember them sometimes. Or if you forget them, you can kind of recreate them in your brain, right? Or actually write them out and recreate them. All right, now what they tell us about this is that they tell us the cosine of the angle that we're looking for and that it's in quadrant 2. So pi over 2 and pi. So I'm looking for theta is in that quadrant, right? So theta is in this quadrant. So I know that cosine is going to come out to be negative here. And they actually already gave me the cosine, right? So in this case, drawing the triangle is actually kind of unnecessary. Now, the only reason, because I already know the cosine, so I could just plug it into the formula. The only reason why I might want to think about where it is so that we can decide whether it's going to be positive or negative out front. Okay, so there's two ways that we can go about this. We could just simply do it algebraically, right? So I know if theta is between pi over 2 and pi, so I know theta is in this region. That's where this angle is from, this angle. But the angle that we're solving for is half as big as that angle. It's not actually theta, it's theta over 2. That's what we're finding the sine for, okay? So we need to know where theta over 2 lives. If theta lives in this quadrant, how would I figure out where theta over 2 is? Well, I would divide it by 2. And if I divide that one by 2, then I get to divide all of these by 2. So that would tell me, it's not going to tell me exactly what theta over 2 is, but it is going to tell me where it lives. So now I know that theta over 2 lives between pi over 4 and pi over 2. So I know the angle I'm looking for is somewhere in here. Theta is somewhere in that region. Okay? I don't exactly know how big it is, but it's bigger than 45 and smaller than 90. So that tells me something important about its sign. Where would its sign, which kind of sign would its sign have? Would it be positive or negative? And of course, everybody knows that students take, all students take calculus. And so we know that all of them are positive in this quadrant, sine is positive in this one, tangent and cosine. And so we know that since it's in quadrant 1, it actually doesn't matter whether they're asking me sine or cosine, they're both going to be positive there. So I'm taking the positive one. So when I plug it into the formula here, I'm going to use the positive. So they told us that the cosine was negative 3/5, and I'm going to plug that in here. So I'm going to have positive, because I know what quadrant theta over 2 is in. I'm going to have 1 minus our negative 3/5 over 2, and then it's just a matter of simplifying this. So it'll be 1 plus 3/5, right, over 2. So what's that, 7/5 over 2? No, 8/5, sorry. 8/5 over 2, which is, of course, 8/5 times a half. So 1/4. So it looks like 4/5, the square root of 4/5. Sorry, I made it kind of messy here. It's all over the place. Which, of course, is is 2 over the square root of 5, because the square root of 4 is 2. 5 we can't do. For me, this is a perfectly acceptable answer. I don't care about rationalizing. But if you're trying to pick it off of a multiple choice exam or check it with the back of the book, they're going to rationalize it. So they're going to multiply by root 5. So it's going to be 2 root 5 over 5. So this is the answer you're going to find on your multiple choice section. And 2 root 5 over 5 sounds good. Okay? We'll do another one because, we'll do another one. And then we'll do the other one kind of just reasoning it out. So let's just take, let's take this cosine one. Let me get another sheet of paper. All right, let's do cosine, pi over 2. Not pi over 2. I keep saying pi over 2, but I mean theta over 2. Okay, so we have cosine of theta over 2. I I'm going to use my cosine formula, but everybody knows that my cosine formula is kind of a problem because it has that plus or minus. So cosine of theta over 2 is going to be plus or minus 1 plus cosine theta over 2. Okay. So, and they tell us that it lives in quadrant between the quadrant that falls between pi and 3 pi over 2. So what quadrant is that? That's this quadrant over here, because this is pi and this is 3 pi over 2. So I know my triangle has to live here, and I always just draw it. I don't try to make it look like this. I just draw any triangle, it doesn't matter, and then label the sides the way I want them. Now, a lot of times when I see this number, I know that happens to be the same thing as this, right? Because they've rationalized it. So a lot of times I just unrationalize it. You can use these numbers, it doesn't matter, or you can use these numbers. Either way, you're going to get the same thing. These are just, all root 3, a multiple of root 3 bigger than these ones. And so your answer is going to come out the same. But a lot of times I unrationalize them. And I guess my brain just automatically does that because when we solve trig equations, this one is harder to understand what it is than this one. So a lot of times I just go ahead and change it that way. But it doesn't matter which way we label the triangle, as long as we're doing the right sides. So we know that we're looking for tangent. So the opposite is going to be the top. So if you labeled it a 1 or you labeled it a root 3, we'll use the root 3 because that's probably what you did. But like I said, I like this better just because you get smaller numbers, right? And then you would automatically know what this one was, right? Because 1 root 3, you know that this one is a 2. But this one's actually going to be 2 root 3 now. So again, if it's me, I'm going to divide them all by, the root 3. And I'm going to get the 1 root 3, 2. So opposite. So either way you think about it, it doesn't really matter. Okay? But these numbers are easier to put into your formula. So I'm going to use my little green numbers. Okay? All right, now how are we going to decide whether to use the plus or the minus? So here's the thing. I could write this out again and just divide them all by 2, like we did last time. That's perfectly fine, and that's easy to do, but we can actually use reasoning like we did in class when we did something like this before. And I said if it has to fall into this quadrant, right, the biggest the angle could be is 3 pi over 2, right? So if I cut that angle in half, if I cut 3 pi over 2 in half, that would give me a 3 pi over 4. So that means if my angle is the biggest it could be would be 3 pi over 4. And where does 3 pi over 4 live? It lives in this quadrant, right? And pi, if we divide pi by 2, then we know that it has to, the smallest it would be pi over 2. So we know that it has to be somewhere between pi over 2 and 3 pi over 2. We know that that's going to fall in here. Or you could think about it like this way. Yeah, I guess that's the best way. Just think about if we cut this one in half, it can't actually be pi because it says that it is, I guess it could be pi. It says that it could be less than or equal to pi. So it could be pi over 2, but that's the smallest angle that we could have. And then the biggest angle that we could have is 3 pi over 4. And it's actually kind of the same way as doing this one. Like it's that same idea, so that we're doing between pi over 2. But I'm thinking about it more visually. And we did something like this. And we, in class, we did it with degrees because it made it a little bit easier, right? If the smallest the angle can be is pi, then if 180, when I cut it in half, the smallest it could be is 90. And then if the biggest it could be is just a little bit less than 270, and I cut 270 in half, then this, like we know that it has to be a little less than half of 270, which is going to fall in here too. Okay, so we know what quadrant the theta over 2 is going to fall in because we know that 3 pi over 4 is here, and we know, so it's going to fall somewhere in here. Okay? That tells us that if we're looking for cosine, then I want the negative, because cosine is negative in that quadrant. Okay? And now it's just a matter of plugging in the cosine into the formula and picking the negative. So I'm going to have negative 1 plus cosine of this one. Let's put in our positives and negatives so that I don't get the wrong answer. So it's going to be, oh, well, I'm using these green ones I just said, but whatever. Yeah, I'm going to use the green ones. So this one is root 3, this one is 1. So these are negatives. So it's going to be, what are we looking for? Cosine. So we're looking for negative root 3 over 2 over 2. And once again, you can use the other ones. It'll simplify the same. It'll reduce the same, but I'm just going to use these smaller numbers that are kind of already reduced in my brain. Now, to get this to reduce to be one of the answers, or simplify to be one of the answers that is your multiple choice, I'm going to break this apart into 2 fractions. So this becomes a negative. Hopefully you saw that. So that's where that negative comes from. And this is just, I put each of these over 2. So this becomes 1/2 minus root 3 over 4, because this is root 3 over 2 times a half. Dividing by 2 is timesing a half, right? And then they actually go ahead and they make this 2 over 4, right? So they do 2 over 4. And then they write it like this. And of course, don't drop your negative. And then they take the square root of 4, which is 2. So you're going to see this as the answer that you're looking for on your multiple choice. And let's see if I got it right this time. So negative, here he is, right? You see it? So for these half angle ones, what are you doing? You're figuring out what quadrant theta over 2 lives in, and you're picking the correct sign, positive or negative. You're drawing the angle theta in the quadrant that it told you theta lives in. So theta lived in this quadrant, you know, it lived in between pi and 3 pi over 2. And so I drew him there. I label the sides so that I get the right sign for the inside of the radical. And then you just have to simplify that all up. And that's just simple, like, radical algebra. Okay, so those are using your half and double angle formulas. So see if that helps.